The Indian subcontinent is dominated by a single, massive hydrological network. The Ganga River Basin covers nearly 860,000 square kilometers. That accounts for 26% of India's total landmass. Within those borders live over 500 million people, making it the most densely populated river basin on Earth. Supporting 500 million lives and an enormous agricultural economy requires a continuous, astronomical volume of fresh water. This river system operates as a biological and economic engine, physically driving the survival of the entire northern subcontinent. To understand how this system generates that kind of volume, we have to look up into the extreme altitudes of the Himalayas in Uttarakhand. At 3,900 meters above sea level, the ice of the Gangotri Glacier melts at a point called Gamuk. This steady release of freezing water creates an initial stream known as the Bhagirathi. The Bhagirathi falls rapidly, cutting a steep, high-velocity path southward through the mountain gorges. After carving its way through the rock, it reaches the town of Devprayag. Here, the clear current of the Bhagirathi collides with the sediment-rich waters of the Alaknanda River. From this specific point of confluence onward, the combined waters take on their official classification, the Ganga. By plummeting thousands of meters from its frozen source, millions of tons of potential energy are converted into raw kinetic power required to push this water all the way to the ocean. The Ganga embarks on a 2,525-kilometer journey, flowing from Uttarakhand through Uttar Pradesh, Bihar, and West Bengal into Bangladesh. Exiting the mountains at Rishikesh, it encounters a drastic topographic shift. The severe Himalayan incline gives way to a nearly flat expanse. Over its remaining 1,600 kilometers, the riverbed drops only 1,100 meters in total elevation. Because of this shallow gradient, the water loses its downward momentum. As the current slows, the river is forced to drop its massive suspended sediment load, averaging 1.4 billion metric tons every single year. Over thousands of years, this continuous, heavy deposition of silt and sand physically built the thick, fertile soils of the Indo-Gangetic Plain. Millennia of sediment deposition and the river's specific geological mechanics physically engineered the North Indian landscape from the ground up. As the main stem travels east, it absorbs a complex network of tributaries. Rivers like the Ramgamba, Gomti, Ghaghara, Gandak, and Kosi flow down from the Himalayas on the left bank, delivering heavy volumes of water and sediment. The Kosi River, in particular, carries an immense sediment load into the flat plains of Bihar, forcing its channels to rapidly choke and shift direction. When these channels migrate, the river breaks its banks, causing severe seasonal flooding that routinely destroys infrastructure and submerges settlements. To the south, a different hydrological system feeds the right bank. Rivers like the Yamuna and the Son originate in the unglaciated peninsular plateau and flow upward to join the Ganga. Unlike the glacial rivers to the north, these southern tributaries are rain-fed. Their water levels fluctuate heavily with the seasonal monsoons. By drawing from two entirely different geographic sources, constant glacial melt in the north and seasonal rainfall in the south, the basin guarantees a powerful perennial flow that protects the region against drought. The combination of thick alluvial soil and a reliable year-round water supply creates optimal conditions for extreme agricultural productivity. Farmers up and down the basin leverage the river to cultivate highly water-heavy crops right along the banks, producing massive yields of rice, wheat, and sugarcane. The surrounding environment benefits in equal measure, with the river sustaining complex, protected ecological biomes like Jim Corbett and Rajaji National Parks. Moving eastward into West Bengal, the water reaches a critical infrastructure juncture, the Farakka Barrage. Here, the river is physically divided. The main branch enters Bangladesh as the Padma River, while a secondary distributary is diverted southward through West Bengal as the Bhagirathi Hooghri. This bifurcation marks the end of the river's role as a centralized agricultural engine and the beginning of its transition into a sprawling, complex estuary system. In central Bangladesh, the Padma converges with the Brahmaputra and Meghna rivers, spreading out and forming the largest river delta in the world. This final expanse is known as the Sundarbans. It is a vast network of tidal forests and deep peat deposits, characterized by dense mangrove roots adapted to survive in the brackish mud. These tidal waters provide the exclusive habitat for rare apex predators and threatened species that rely entirely on the health of this acidic aquatic environment to survive. Today, that health is challenged by severe pollution and reduced flow. In response, modern countermeasures like the Namami Gange program are actively building sewage treatment infrastructure and enforcing biodiversity protection to restore water quality. Securing the future of the Ganga River Basin preserves the biological circulatory system that supports a quarter of India's population.